Morning, ladies and gentlemen. Augmented reality. So what I talk is about the projection of the information, and we talked a lot about information, but how are you going to project that to the mariner? That's the task that I have been thinking of. But first of all, I'd like to ask the question: well, do we dislike humans? I mean, if we study carefully accidents, it's most of the time we have a tendency to say, well, it's the human factor that spoils the whole show. So let's get rid of it and let's get more automation in it. Let's get more machines doing the task. Get rid of all these human errors. But in the end, it is of course the human who does the job. So I guess the answer to this one is no. We don't dislike humans. We like the human on the bridge. The second question is: are we monitoring navigators? Well, that's a new type of phrase, monitoring navigators. I don't exactly know what we mean by that, but being a navigator myself, I don't call myself a monitoring navigator, no. So what do we do on the bridge? It can be quite futuristic. This is a picture I lent from a Rolls-Royce design, and what you can see here is quite futuristic. We see men on the bridge, humans that we like, of course, but we see also augmented reality. There is something projected on the screen, on the windows. We see the ice fields, we see a lead, we see a ship. This might be a real ship, but it might also be a real ship in combination with a projected information, and it actually says something about the ship. Maybe AAS information, maybe course and speed, etc. Suggested routes can also be shown here. And although this might look very futuristic, I don't believe that this future is so far away. But first of all, let me ask some imagination from you. Suppose you are the second officer and you are doing the midnight to 4 watch, and you start working again at 5 AM because the ship is entering port. You start berthing, you open hatches, you help opening hatches at 7, you have breakfast, you receive port state control for inspection. That's a long day. You have a hot meal at 11:30, and then at 12 o'clock your watch starts again until 4. And then you have some time to do your administration, you have a short supper at 5:30, and then you assist again in hatch closing, unberthing, and at 7 you will be able to rest some hours again on watch at 12 o'clock. Is that just an ordinary day? Yes, it's not uncommon to have such days. But please imagine a little further. Watch, dark night, nothing really going on, not exciting. Watch keeping is not exciting at all. And at 1:45, you have a new moon, rainy night, North Sea, poor visibility, leaving your traffic separation Fleeland Junction. Only a few ships ahead, some fishermen, vessel behind you. But then suddenly, an alarm, collision warning, unexpectedly. What is going on? Where? That takes valuable time to find out where the problem is. Sometimes you don't have that time. Would it help if you can provide the watch officer with a visual clue about the direction where to find the alarm? Would it help if you have a head-up display? Might be a goggle, might be a projection on the windscreen, that's irrelevant. And would it help showing the real outside world together with a synthetic marker on top, thus speeding up detecting the target and take evasive measures? Anders talked about situational awareness, and we think that this augmented reality can add to this situational awareness just by providing visual clues on the outside world. So that can look like a picture like this. You have this outside world, and you have maybe on your windscreen or any other means of projection, you have this box pointing out this is the target that is of interest to you. The rest of the world is of less interest. So that can help. And of course, it still holds true that the watch officer shall always be alert and he shall always act timely and comply with the collision regulations. Yes, yes, that's true. But yet, ships do collide, ships run aground. That's a fact. So, although we ask people to act accordingly to their to the law and to navigate safely, but still accidents happen. And what can we do to bring that number of accidents to a comfortable level of what I would say 0? Because I think that 0 accident should be the policy. We shouldn't accept failures. So what do we need for that? We need some input, and that's the next slide. We need something about your own ship, maybe speed, course, positioning. We need some information from the AAS, from the ARPA. Sometimes we need the position of the watch officer on the bridge in order to compensate for the parallax error. If you position the augmented reality on the windscreen, the system must know where your viewpoint is. So all this information goes into this processing unit, and it can calculate CPA times CPA, maybe calculates a risk index or a relative bearing and a relative distance. This relative bearing and relative distance is going into some projection module, and so you can decide what kind of symbols you like to use, what kind of color you like to use, maybe dynamics, a flashing image or a moving image. And then you can send it to maybe a cubicle, like the futuristic bridge design we saw a few slides ago. But you will see another way of projecting it in the next slide. And we should have some user control about alarming thresholds, because in this calculation of the risk index there is some algorithm that determines the risk of the vessel. And this is not something static. Not all vessels within 3 miles CPA are dangerous. If you, for instance, sail the Kiel Canal, the chances of passing each other on a distance of maybe 50 meters is quite high. And those are not dangerous vessels. So you must have some user control in order to adjust the alarm thresholds, and in order to have the human being able to adjust the alarm level to the levels that he or she needs and finds workable and effective, I mean. Apart from that, we can also introduce external information. Maybe you have information from the VTS, or maybe information from MSI. That also can be incorporated into this processing unit and also be able to project it on maybe the screen or maybe a goggle. So this futuristic thing is not so far away. And what I would like to show here is maybe the rest of the information. Apart from this target over here on the starboard side, we can show the suggested route that Anders talked about, but also what Jan-Hendrik talked about yesterday. Marine safety information. If you can display that on your window screen, I would say, and I just draw, this is a mock-up, this is not reality yet, and I just draw some symbolic thing here, but my estimate is that any mariner will not enter this area if it is shown as a red fence of an area, and apparently an area no-go. So our initial idea to create this augmented reality thing is to create a sort of a cocoon where you have displays around you, and these displays can be created as transparent, so you can just look through the display and then have a synthetic image projected in the display. So you have the combination of the real world outside and the synthetic picture in this display. However, talking to the manufacturers, it turned out after a year that they couldn't deliver us the big displays. We had ordered 57-inch transparent displays, but that was a no-go, unfortunately. So we had to go for another route. So what we ended up was this thing, which is an augmented reality goggle, and this is a prototype. You see me sitting here at the fast ferry bridge at Terschelling, looking at an icy area. But what I have here before my eyes is two lenses, and these lenses have about 70% transparency. So that means you see 70% of the outside world, which is in this particular case a synthetic outside world, but you can use it in the real world as well. The other 30% of this augmented reality goggle can be used for this synthetic picture. So, and in fact it is just an extended VGA monitor inside the lens that is 70% transparent. So that gives me the possibility to introduce all this information in my augmented reality goggle. And how does that look? That looks about this way. This is also a combination from SMM. And what you see here is the synthetic picture on a monitor. So that's not in the goggle, but well, it is, let me correct that. It is the picture that you will see in the goggle, which is now displayed on the monitor. And you see here the bore sight, so this is the heading marker of your vessel, and you can see here the AAS information, and it has some symbolics in it. This is still in the development phase. You can see big circles with red colored and smaller circles with white colored, and you see here the text messages, which is in fact the AAS information. If you combine that with the outside view, and this is not perfect, but the idea is clear. If you combine that, you will see the heading marker, which should be here, of course, so it's slightly unaligned. But the idea is that you have the heading marker on top of your outside view, and you have the AAS information in your goggle. And of course, this big red circle should be here for the target that is a little bit on a worrying course. Any mariner can see that with his own eyes, but so this is the idea of the augmented reality. And as I said, we are able to do this right now. And if you take the opportunity to visit us in the Leeuwenborg room, we do demonstrate this augmented reality goggle in combination with the Transat simulator from our colleagues of Flensburg. And my personal experience with it is that your brain needs some adaptation. When I first had this display on my head, they showed me a picture or a movie in this goggle, and I could clearly follow the movie and look at the outside world. So having a goggle on it, I could watch you sitting there and watch a movie as well. But and I could concentrate. My brain could concentrate on that movie. But by the moment that I turned my head and this outside view would change, and my brain immediately started to concentrate on the outside world. So that the message behind that is that we need some training before we can use this augmented reality. So this is a new phase in man-machine interfacing that you need to train to use augmented reality. Another observation, also in line with Anders, his observations with the pilots in the Humber area. When we demonstrated this at the SMM fair last summer, I got a visit of a few German old salt sailors who had been at sea for over 150 years or something like that. And they came with this argument, well, no more monitoring on our bridges, no more machines, no more computers, it's enough. And then you talk to them and explain them what it is, and then even after 10 minutes, just talking to them what the idea is and how it can work and how it looks like, they went off and said, dat könnte mal wat zijn, eh? So that could be something of value. So, of course, user world has some time to adapt to it, and needs some time to adapt to it. But if you explain what it's all about and how it can work and how it can help them, then it's most of the time it's okay. Another observation is sitting there with a 600 grams of monitor on your head is no fun after an hour. So I immediately recognized that this augmented reality goggle is not the most comfortable thing to work with. However, we use this as a prototype just to study what augmented reality can do, just to study how symbology can work, just to study how the interaction of a human with augmented reality information is and can be in the future. And we can test this on the simulated environment, so we can test situations again and again and again with several types of persons and several amounts of experienced people. But I envision a much more comfortable situation where you have transparent monitors around you, and I still believe that it's just a matter of time that the monitor manufacturers can produce these big monitors where you can look through and have an image projected in it. And it might even be a touchscreen monitor, so that you have screens around you in your cocoon. You might have a cocoon for the captain, a cocoon for the pilot, a cocoon for the helmsman, I don't know. And then you have a sort of a touchscreen where you can monitor the vessel. And one of the guys who do the programming, they go airborne when they talk about this, and they say, well, you can even create window blinds. If you have the sun coming in, you can create a virtual window blind, and then you can block the transparent monitor for too much sunlight when you use it in daylight. So if you can imagine, then I think there's no limit anymore. So there are still some issues to solve, but these are not too complicated. You should introduce some correction for the pitch and the roll and the heave of the vessel. You should correct for the position of the watchkeeper, because if you project it on the window screen, you have some parallax effect. However, if you use the goggle, that's another side effect of using the goggle. You don't have to correct for the pitch and the roll, and you don't have a parallax effect. But this third bullet, that's a very important one. What's the reliability of the third-party information? So can we rely on AAS information? Well, that's a discussion in itself. But that goes apart from augmented reality. Let's focus on augmented reality, that's one thing, and the reliability of the third-party information, that's another topic. But we need to solve that. One suggestion I got was, well, why not use radar information? Maybe the radar ARPA information, we can project that in augmented reality goggle as well. But you could also use the raw radar information. So if you have the raw radar picture and you can project it in your augmented reality goggle, it's okay. And experiments in Japan show that they use these raw radar images and have it transformed and projected in their augmented reality goggle, kind of goggle they have, and then it works. So you have this integrity check. Okay, that's the fourth bullet already. And the last one, that's the interesting part. How does this have an effect on the watchkeeper? I learned from yesterday that cars which have an automatic brake do get involved at a much lesser intense, in much lesser times. But my question is, if you would drive a car with an automatic brake, in the city and it is 3 o'clock and schools are out and children on the street, would you be much more carefully driving if you know that you have a car that automatically brakes if a child is on the street? I don't really, I'm not sure about that. My point is, will this automation, will this automatic warning for the dangerous cars in your area, will that make you a bit more comfortable in your position, in your chair, and say, well, the system wakes me up in time, or is it a help in avoiding accidents? And that's something that we have to test. So we're not ready yet. But it is all embedded in the e-navigation prototype solution. So I would say we can combine this in the tactical route exchange that Anders talked about it. We can introduce the dynamic no-go areas. That's also a prototype solution of ACCSEAS and other projects. We can introduce the route topology modeling in augmented reality. We can introduce the resilient PNT in it. We can introduce the maritime cloud in it. So if you take this concept of augmented reality, there is not much limitation in this way of projecting information. That's all for it. Thank you.